let's get into some, I think, newer material. What if you have x plus y multiplied by a plus b? All right, now this is different. This is different than anything we've done before right here, because up until now we've had kind of one thing on the outside of the parentheses. Could have some stuff multiplied together, but it's one kind of term out there. And you open up your parentheses and you've got some stuff add together in there. We know that we have to distribute everything in. That's what we've been doing on the previous board. This is a little bit different because what I have out in front of this set of parentheses is actually a larger polynomial with two terms. So a lot of students, when they see this, rightly so, don't have any idea how to proceed. And so it's a little bit cumbersome at first. So what I'm going to do is show you how to do this using only what we already know so far, and then I'm going to generalize it to what you probably have heard in your class called the FOIL method that your teachers are probably teaching you. A lot of students learn the FOIL method and they kind of understand what FOIL is. It's a way to multiply things basically. But what they don't understand is, where does it come from? Where does FOIL come from? Why did they just make this FOIL up? So every student learns the FOIL method of multiplying polynomials in algebra class, but you don't really ever learn about where it comes from, or the fact that it's something that makes total sense based on what we've been doing so far. So what I'm going to do here is show you how to multiply these things together and then show you how it ties into what we call the FOIL method in a few minutes. So notice we have this set of parentheses and we have another set out front. What you need to do is treat this out front as as its own thing, and what you're going to do is distribute it in like this. Right? So this makes sense based on what we've been doing so far. So it's not a new rule, it's just whatever's out in front, you distribute the whole thing in. So the way you would do this, all right, is you would have x plus y times a, because they're multiplying it times a, and then you would have plus x plus y, and you'll be multiplying it times b. So that is what happens when you distribute it in. But when you do that, you realize that you can distribute this a in like this, and you can distribute this b in like this, right? Because everything's multiplied together. So really what you end up with is a times x, because ax, plus a times y, ay, plus, here we have bx plus by, because we're just distributing these guys in. So here I have four terms, right? This represents the original thing that we were trying to multiply together, right? And we did it using all the ways and the methods that we used before. We take the thing on the outside, we distribute it in, then we realize we can distribute a second time. All right, so when you think about this, right, a times x is the multiplication of these two terms. These are called the first terms, right? The f terms. So let me put an f here. All right. Over here, by, these are the last terms. When I say first and last, I mean this is the first term, this is the last term in this guy. This is the first term, this is the last term. So we take both of these and multiply the both first terms together. We take both of these and multiply, these are the last terms together, right? And over here, a times y, these guys, these are what we call the inside terms because they're kind of close together on the inside. And these guys right here, the b and the x, these are the outside terms because they're far apart. So you have FIOL. And if you rearrange this, because everything's added together, so you can kind of rearrange these terms, what you can really get is FOIL, which is called FOIL. This is the way you typically learn how to multiply something like this in algebra. The teacher tells you, or the textbook tells you, multiply the first terms together, then the outside terms, then the inside terms, then the last terms, and you add them all together. So you have plus signs in here. And when you do all of these little multiplications and string them along, that's what you get when you multiply two polynomials like this, two binomials. These are binomials because I have two terms here and two terms here. So this is fine. Using the FOIL method is fine. It's a great way to remember how to do it. But I just wanted to make sure you know that the FOIL method doesn't come out of thin air. It doesn't just pop up as a new rule in algebra. Suddenly you have to memorize a new rule. You know, students think there's lots of rules in algebra and there's so many to deal with. Well, really, there's not that many rules. They just build on each other and they get generalized. So this comes from just regular old distribution, just like we've been doing before. So I just wanted to make sure you know that. So let me erase the board, and what we're going to do next is work a FOIL problem. Actually, we're going to work several problems where we're going to multiply using the FOIL method. All right, what if I have a plus 4 times a plus 5, and I want to multiply these together? Well, I could certainly do exactly what I did before. I could treat this as one unit. I could multiply to a, treat it as a unit, multiply times the 5, and then I could simplify the answer and add everything up. And that is correct. That is absolutely correct. And if that is the way for you to remember this, that is fine. But I am going to teach you to do it with the FOIL method because it is easy to remember, and also because most teachers are going to kind of insist that you know that you know what it's talking about. So when you see a binomial multiplied by a binomial, you pretty much are going to use the FOIL method. So it's very simple. First, we have to spell FOIL. F-O-I-L, right? So the first terms are going to be the first of each of the first terms inside the parentheses. So a times a. We're going to multiply that together, and we're going to get a squared, because that's what a times a is. Then we're going to do the outside terms. The outside terms are the ones on the ends. A times 5, you can rearrange that to 5a. Then we're going to do the inside terms. 4 times a is 4a. And then we're going to do the last terms. 4 times 5 is 20. And everything is added together with plus signs because there's no negative numbers or anything in there. And so the answer is a squared plus 5a plus 4a plus 20. However, you'll notice I have a like term here and a like term here. So I can simplify this. A squared plus, this is like with this, so 5 plus 4 is 9a plus 20. So the answer to this multiplication is a squared plus 9a plus 20. So I want to stress that using the FOIL method is fine. First terms, outside, inside, last, that's fine. But it all comes from just basic distribution of whatever's on the outside in. It's just a shortcut way to remember that. It's not a new rule. It's not a new lesson. It's not really anything new. It's just a way for you to remember without having, because some students will get confused on this kind of stuff, but I tried to present it in a way that wouldn't necessarily confuse you. So for our next problem, let's say we have 3x minus 2 multiplied by x plus 4. And so here I have a binomial here and a binomial here. So anytime you see a binomial times a binomial, you're going to have to use the FOIL method, or if you want, you can distribute it in just like what I showed you, but the FOIL method's probably a little bit easier. So what you're going to do is hit an equal sign here. First, you have to spell FOIL. So the first terms come first, F. So the first thing we need to do is look at our first terms. The first terms in each set of these parentheses, 3x, and multiply it times x. So what we're going to get is 3 times x squared, because x times x gives you x squared. Next, you look at the outside terms, right? 3x times 4 is going to give you, it's positive 3x and positive 4, so positive 12x. Just multiplying the outside terms. Then you look at the inside terms. Now don't forget, this is a negative 2 because you have a negative sign here. So negative 2 times x is going to give you negative 2x. Right? And then you have the last terms, these guys here. Negative 2 times 4 is negative 8. All right, so that is the answer after you do the multiplication. But you're always going to be able to simplify these things because you have a like term and a like term. I have x terms there. So I'm going to have 3x squared plus 12 minus 2 is 10x minus 8. So the answer is 3x squared plus 10x minus 8. All right, so now we're cooking, and we're just going to get a lot more practice. 2a plus 4 times 3a minus 5, and we just need to multiply these guys together. So again, we have binomial times binomial, so we're going to use the FOIL method. So we identify the first terms. These are the first terms, 2a times 3a. 2 times 3 is 6, a times a is a squared. And then we go to the outside terms. These are the outside terms. 2a times negative 5 gives me negative 10a. This 2 times 5 is 10. Of course, you have a negative, and then you have the a there. And then you have the inside terms, FOIL. 4 times 3 is 12a. It's positive because I have positive numbers in both places. And then I have the last terms. These are the last terms. Negative 5 times 4 is negative 20. All right, and so that's basically the result of the multiplication, but as always, I'm going to have some like terms here. So what I'm going to have is 6a squared. This is a like term with this. What's negative 10 plus 12? If it helps you, you can flip it around and say 12 minus 10. That's going to give me positive 2a minus 20. So basically, you add these coefficients together, you keep the variable along for the ride, just like we did in the last couple sections, and there you go, 6a squared plus 2a minus 20, and that is the answer. All right, now what if we have another problem? Let's say we have 2 times t plus 3s, 3t minus s. I have this problem here mostly to show you that you don't have to have numbers only in the second spot. It could be anything in here. This is a two-term polynomial. It's called a binomial. Here you have a binomial. But you use the FOIL method no matter what you actually have inside of here, letters or numbers. So first you identify the first terms, these guys. 2 times 3 is 6. T times t is t squared. Right? And then you look at the outside terms. Here you have 2t times a negative s. So you have a negative times positive. So you have negative 2ts. All right? The negative comes from the fact that it's a negative s times a positive 2. Negative times positive gives you negative. The inside terms, you have 3 times 3 is 9. And then you have s times t. But I'm going to write it as t times s because I know I'm going to want to combine him later. And you can flip, since they're multiplied, you can flip it either way you want when you do multiplication. And the last terms, you have 3s times negative s. So you have negative 3s squared because s times s is s squared. So those are the results of the multiplication. I have a like term here with a like term there. So what I'm going to have is 6 times t squared. What is negative 2 plus 9? It's going to give you 7 ts minus 3s squared. Now all of these are different terms, so I can't combine them anymore. None of them match, so this is the final answer. And the bottom line, if you haven't seen the pattern up to now, most of the time when you're multiplying binomial times binomial, you're going to get something, you're going to simplify some like terms, and you're going to end up with 3 terms in the answer almost all of the time. Okay, what if you have simply x plus y times x plus z? Binomial times binomial. It's the same story, different chapter every time. First terms, x times x gives you x squared. Outside terms, x times z gives you xz. Inside terms, y times x gives you y times x. There's nothing much more to do there. And then the last terms are these guys, y times z. Right? So y times z. So in this particular case, you can't simplify anything after you do the initial multiplication because here you have x squared, xz, yx, and yz. So none of them match. Even if you try to flip any of them backwards around, none of them match. So the final answer is x squared plus xz plus yx plus yz. And that's the final answer. So what if you have something a little bit bigger, like 4 times t minus u, negative 3t plus u, like this. So what you're going to have is the first terms, these guys. 4 times negative 3 is negative 12, and t times t gives you t squared. And then you have the outside terms. 4t times u is going to give you 4tu. Can't really do much more with those because they're different variables. The inside terms, negative u times negative 3t is going to actually give you a positive because negative times negative is positive. And then you have 3tu. I mean, you could write it as ut, but I'm going to flip it backwards because I want it to match one of my other guys so I can combine them later on. So 3 times t times u. As long as you have all of them there, you're fine. And then you have the last terms. Positive u times negative u is going to give you negative. U times u is u squared. So here's what we have, but notice that I have some like terms. That's a like term with this because I have tu and tu in both places. So finally, I'm going to have negative 12t squared. 4 plus 3 is 7tu minus u squared from over here. This is the final answer. Negative 12t squared plus 7tu minus u squared. All right, here I have r plus 4 times r minus 4. All right, not too bad, but I want to make sure and do this one for you to make sure that you understand and kind of see something here. Okay, first terms are going to be r times r is going to give me r squared. Outside terms, r times negative 4 is negative 4r. Inside terms, 4 times r is 4r. And the last terms, 4 times negative 4 is negative 16. So here we go. Now I look for like terms, and I immediately see I have a negative 4r and a positive 4r. So really, 4 minus 4 subtracts to give me 0. So what I'm left with is r squared minus 16. That is the final answer. And I just wanted to point this out to you because, normally whenever you do these multiplications, you're going to get some kind of like terms. And so most of the time when you combine everything, you'll have 3 terms in your answer. That's mostly what we've had. But occasionally, if you get a cancellation like this, it could wipe itself out and you only have 2 terms in the answer. So not something you have to memorize. I was just pointing it out to you to show you that depending on how the things add in the middle, you might have a term drop out like we have here. All right. Now let's switch gears a little bit. I think we've done enough of the FOIL method to show you that it's pretty easy. You have a binomial times binomial. I showed you how to multiply it. I even showed you where it came from, which is just basically distribution in. So what if you're given something that looks a little bit crazy like this? 4 times t plus 3 multiplied by t squared plus 2 times t plus 3. Now this is totally different than anything we've done in this lesson because typically we've had binomial times binomial. Here we have binomial times trinomial. And this is not something you're asked to do too often because a lot of students choke and don't know how to proceed. You immediately know that you can't do FOIL on this. At least you can't do it with FOIL because you have too many terms over here. So FOIL only applies if you have binomial times binomial. That way you have FOIL. It only applies as a memory mnemonic, as a memory helper, when you have binomial times binomial. So here we have binomial times trinomial, so FOIL is going to not really help us because it's set up for that special case. And I distribute it into here, distribute it into here, and distribute it into here, right? And that is true. You could definitely do it that way. Let me show you another way, just to kind of not really blow your mind, but just show you that algebra makes sense. So we could definitely take this unit and multiply times this unit times this unit times this, but we can also do it like this. I can take the 4t, I can multiply it in like this, and then I can take the 4t to here, and I can take the 4t into here. And then after I'm done with that, I could take the 3 and multiply it into here, and take the 3 and multiply it into here, and take the 3 and multiply it into here. Basically, forget for a second that I have 4t plus 3. If I only had the 3 out here, it's very simple. You have to take the 3 times this, the 3 times this, and the 3 times this. That's what we've been doing all this time in algebra. If I cover up the 3, it's very simple. The 4t has to be multiplied times this, the 4t has to go times this, the 4t has to go times this. The fact that I have them added together just means that both of those things have to happen in order to do this multiplication. If you have 2 terms multiplied on the outside of a large parenthesis, every one of these outside terms that you have has to get distributed and multiplied into the inside. This has to happen as well. So it's kind of, again, it's not really a new rule. A lot of people say, oh, it's a new rule in algebra, a new rule, it's so complicated. It's not complicated. Everything on the outside has to get multiplied to the inside. Every term has to be multiplied by every other term, and this is the easiest way to do it. So let's just do it, just to show you how to do that. All right? 4t times t squared. Well, that's going to be 4t cubed, because t times t squared is going to give me t cubed, like this. Now, 4t times 2t. 2 times 4 is 8. T times t is t squared. Now, 4t times 3. 4 times 3 is 12 times t, because t is hanging along for the ride. Okay, so what I've done is I've pretended at this point that the 3 is gone, and I distribute everything in, and this is what I get. Now I have to keep going. Plus, I pretend this is gone, and I take the 3, multiply it times t squared. I'm going to get 3t squared. If I take the 3 and multiply times 2t, I'm going to get 6 times t, because 2 times 3 is 6. And if I take the 3 times the 3, I'm going to get a 9. So what I've done is these 3 things arise from taking the 4t and multiplying in, and these 3 things arise from taking these guys and multiplying in. Everything out in front has to cross-multiply into everything on the inside. So now I look for like terms. Well, I don't have any other t cubes anywhere here. So it's going to be 4t cubed. That just stays along for the ride. But I have a t squared here and a t squared here, right? So these match. These are like terms. So 8 plus 3 is 11. 11 what? 11t squared. All right? And then I look for any other like terms. I have a 12t here and I have a 6t here, right? So these are like terms, t and t. So 12 plus 6 is 18t. Right, so those guys there. And then I just have a number. There are no other numbers here, so I just have plus 9 at the end. So the final answer is 4t cubed plus 11t squared plus 18t plus 9. And that's the answer. So most students, if you're given this on a test, if you don't know what you're doing, then you kind of get lost because they don't know how to use FOIL for it. And if you don't know how to use FOIL, see, that's the danger of FOIL. FOIL's cool, but it can get, you can lean on it too much where you don't know what's really happening. FOIL only comes about because you're multiplying everything on the outside times everything on the inside, and then you simplify everything. And so when you make a larger problem, the same thing happens. And so just to kind of, just for giggles, if I continued this and I had, plus, z plus w over here, so I had a much larger, polynomial here, then this problem, now that you know how it works, is very simple. So the 4t gets multiplied times this, times this, times this, and then also needs to get multiplied times this, and then also times this. And then the 3 needs to get multiplied times this, 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 and then also times this, and times this. And then you have a lot of terms that you have to then simplify. So once you know the big picture, then multiplying polynomials in algebra is really just following the same rule, just to larger and larger